Welcome to the 8SP-102 Software Interface Training Module. Here is what's covered. Relay connection. In this session, we'll introduce how to do a quick connect to the relay from a PC running the 8-series setup software. In doing this, we'll show you how to achieve this by using a USB cable, an Ethernet link, and finally using Wi-Fi. Then, we will walk you through the steps of viewing your relay in Viewpoint monitor. Setting files. In this session, we'll introduce how to read and write the setting file, how to duplicate, rename, edit, and compare the setting files, how to create an offline setting file and print that setting file, as well as how to convert SR setting files into 8-series format. Test simulation. In this section, we'll introduce how to set up the simulation test for pre-fault, fault, and post-fault parameters. Actual values. In this section, we'll introduce the metered values of current, voltage, frequency, and power, the status of the breakers and switches, different inputs and outputs, and the records of event records, transient records, and data logger. Quick setup. In this section, we'll introduce 4 different quick setup parameters for the feeder, motor, transformer, and generator protections. Protection summary. In this section, we'll show you how to check the enabled protections and controls and how to quickly access these functions from the summary screen. Upgrade firmware. Here, we'll show you how to upgrade the firmware by demonstrating how to upgrade it from firmware version 2.0 to version 2.2. In the resources section, we'll identify the other key resources to assist you. And finally, we will summarize what we have covered in this module. So, let's get started. The first thing we should do is if you don't have 8-series setup software already installed on your PC, is to find the software needed, download it, and install it on your machine. To do this, you have a few options. You can install it from the CD that comes with a relay. You can install it from the Vista Launchpad, which is a powerful G software and document repository tool. If you want to go this route, then go to the Vista website, and you might want also watch our learning modules and Vista ENR-100. The third way is to download it from the software link on the resources pane of any 8-series web page. When doing this, you should always select the latest version. Now you have the software installed on your machine. Double-click on the icon to open the program, and now we can start to work through the various ways of connecting to the relay. The quick connection function can be done using either a USB cable, an Ethernet cable, or through Wi-Fi connection. For the first-time connections, USB is the quickest. For this, you need a Type A to B USB cable. Now, connect the Type A end to the USB port on the PC and the Type B end to the relay as shown. Then, hit Quick Connect. A window will pop up asking you to select the interface type. In this case, we're using USB. Later, we'll show you how to do this setup using both Ethernet and Wi-Fi. Before we can go further, we need to set the sleep address and the port settings. For this, we need some info from what we learned in the 8SP-101 module. This information can be found under Communication, then Modbus Protocol. Here, we're showing the key information in the form of the front panel LCD screen. In this case, we're using the default setting 254 for the slave address and 502 for the port. Now we can click Connect button. Once the process finishes, a window will appear that indicates that Quick Connect has been successful. If you look at the online window on the top left pane, you will see that Quick Connect has been added to the device list. You can now click on OK to close the open message box. Now that the relay is connected, We can do a quick verification to ensure we are connected correctly. First, we need to log on with our username and password, as we shown in the Learning Modules 8SP-101 hardware. To do this, click on Quick Connect Device under Quick Connect in the Online Windows pane. When doing this, don't forget to select Administrator. Now you can click on the HMI display under Status to bring up a new window showing the relay front panel. If you have successfully connected, you will see the bottom HMI display tab is in green. Now let's change the relay IP address. To do this, in the Online Windows pane, navigate to the set point, then Communication, then Ethernet, and select Network Port 4. A new window will open. Set the IP to 1.1.1.1 and the subnet mask to 255.255.255.0 and the port 4 operation to independent. Then click Save. Please note you should wait 30 seconds and then reboot the relay. Once the relay is rebooted, we'll use this IP address for the Ethernet connection. Most of the time, USB connection will work fine. Usually when it doesn't, it's due to the PC configuration issues. To assist with this, there's one USB troubleshooting guide. This document can be found under the 8 series PC on your local drive at the file location given. There are two types of Ethernet connectors, copper RJ45 and ST fiber connector. When the communication suffix in the order code is standard SE, then standard RJ45 port should be used. If the communication order code is advanced from 1E to 3E and the connector is ST, then optical fiber port should be used. Be careful of the polarity of the relay to the Ethernet switch when using fiber. The transmission terminal TX on the relay should be connected to the receiving terminal RX on the switch, and vice versa. When the advanced communication order code has copper RJ45 connector, then RJ45 cable should be plugged into the advanced copper port. When either type of the Ethernet cable is connected, the relay IP address is set up, then we need to configure the computer IP address. For this purpose of demonstration, we're going to set up the computer IP address to be 1.1.2. So we're going to start the change adapter settings, click local area connection 2, and this is the Ethernet I'm going to use for the connection to the relay. Start the property and TCP IPv4. I set up the IP address 1.1.1.2, so it's different with the relay IP address, which is 1.1.1.1. Using the 255.255.255 for the subnet mask setting, and click OK to accept. Now we want to verify this IP address of the relay. We can start the command prompt, and we can type in the ping command, PING, and relay IP address, which is 1.1.1.1, and press enter. And now we can see this reply message from the relay, means this IP address of the relay is effective. Okay, so shut down this connection. Now we're going to set up this relay under the device setup. Click device setup button and click end site. Give this a site name, Markham, and click end device. We'll give this device name called feeder 101. Then select the interface to be the Ethernet. You can type in the IP address 1.1.1.1 and keep the default slave and port settings. Now we click read order code. Now this relay's order code is populated as well as the version number, and then we click OK. We can see this site name, feeder 8SP-101, the device name, is ended. So now the Ethernet connection is successful. Now let's turn our attention to set up a Wi-Fi connection. To do this, we need a wireless router, a PC, and a relay. In this case, we're going to use two relays to show the settings of different IP addresses. So let's begin. First, we're going to set up the router's SSID. This is done by accessing to the router's configuration setup using the manufacturer's IP address. Start by physically connect to your router to your PC, then open your internet browser and enter the IP info into the address window and your router. Now, go to the wireless setting and take note of your network name, often referred to as SSID. If you are using a new device, set up the network name to one of your choosing. Here we're using uppercase LD, then save. The second step for the router is to make sure that the security settings are correct. You should select WPA2 personnel as shown here and set a password to secure your network. Now that we have the router set up, let's move on to the PC settings. We need to go to the Wi-Fi network connection and then select Internet Protocol version 4, referred to as TCP/IP v4. Now we will review its property and a second window will open with a tab called General. Here we need to check the use of the following IP address and then set the IP address to 192.168.0.2 and the subnet mask to 255.255.255.0. Now click OK to accept these settings. So now let's turn on the Wi-Fi button from the laptop, search available wireless network connection, choose LD and click Connect. Enter the passphrase PA55WORD. The default IP address is automatically assigned based on the serial number of the relay. The calculation is a modulo 242 of the last 3 digits of the serial number plus 12. For example, when the serial number is 1, then the last octet will be 13. When serial number is 241, the last octet will be 253. When the serial number is 242, the last octet will be 12. This is to ensure uniqueness of the default IP address for all 8 series devices present on one wireless network, and it creates a usable address space from 192.168.0.12 to 192.168.0.253 for 8 series devices. For here, we just set it to 192.168.0.12. Then, under Wi-Fi security, choose WPA-PSK, set SSID to LD to match SSID of access point, then set up WPA2 passphrase to PA55WORD. Now we'll create a new connection with the interface set to Wi-Fi. Next, type in the relay IP address 192.168.0.12. Then click on the Read Order Code button. Then the order code will be displayed, and now your Wi-Fi connection is successful. Now we'll guide you through how to use an Vista Viewpoint monitoring software with 8 series relay. The prerequisite for this session is that you have an Vista Viewpoint monitor software purchased, or you can download a 90 days trial version. The first thing, we're going to set up the 8 series under device setup by clicking the device setup button, and then we got options. We can choose Ethernet and serial, and for this option we need to choose Ethernet. So we can add a device. I called 845 transformer, and interface we got only Ethernet and serial port. There's no USB. So for our even USB connected with the relay, we still choose Ethernet port. and we use the IP address of the USB connection 172.16.0.2 as the IP address, and use the same slave address and Modbus port address as we showed in the USB connection, and then we can click read order code. So now we see this order code 850 is populated under order code, and be careful, this version it shows only 1.6 and the actual values software from a version of the relay is 2.0. The reason is that the latest and Vista Viewpoint monitor software is version 8. It only can read 8 series version 1.6. So any version higher than 1.6 will be displayed as 1.6. So click OK to close this setup. And second part, we're going to show you how to associate these settings within the single line diagram by opening the one line editor, and we're going to open one sample files. So this is, I got one Markham single line diagram, so I can associate one of the breaker with the device. So by clicking this breaker open, and I can associate this device by selecting the device number. So 845 transformer, contact input 1. So this is associated with the breaker status. So now the status of the relay will be reflected in this single line diagram. And that's concludes this Viewpoint monitor software connection with 8 series part. Once the relay is connected by either USB, Ethernet, or Wi-Fi, we can download the setting file from the relay into the offline windows. To download the setting file, highlight the device name and right-click mouse and choose Read Device Settings. Then we need to select target file. So click Browse to choose the directory of the file you want to use. In this example, we're going to use the default directory, which is under the public document G Power Management 8 Series PC data folder. And we'll give a name, feeder 101, and click Open. Then click Receive button. Now we see a message box reading setting file from the relay, and also the progress bar is moving. Now we see this new setting file is ended into the offline windows, feeder 101, and we can further verify this setting file being also ended into the Windows directory, public document, G Power Management 8 Series PC data folder, feeder 101.cid file. So that's how we download the setting files from the relay. Under the offline windows, we can duplicate one setting file by right-click the setting file and choose Duplicate Setting File. So now we have one duplicated setting file of the feeder 101. By default, its name is copy of feeder 101. To rename this file, we can right-click mouse and choose Rename Setting File. We can rename these setting files into feeder 102 and click Rename. So now the setting file is copied and renamed. We can also verify this new setting file is also ended under the 8 Series PC data folder in the Windows directory. Now I want to compare two setting files, feeder 101 with 102. First, I want to make some changes under the system. So first, I will make the CT sensing primary current from 500 to 1000. The second change is the voltage sensing from Y to delta. And third one will be the power system, change from the 60 Hertz to 50 Hertz. Okay, so now I go to click feeder 101 and right click mouse and choose compare to setting files. Then highlight the 102 and click OK. So now the progress bar reached 100% and we can see the result showing 3 differences between the setting files of 101 and 102 if we click OK. So we can see that the setting files values in the file 1 is 500 for the CT primary, 1000 for the file 2. The VT connection Y for the file 1 and delta for the file 2, and the frequency 60 Hz and 50 Hz for the file 2. So that's the compare result. Another very often used comparison is the compare with the default setting. So to do this, we can right click mouse and choose compare with default. So we can see that your setting file with the factory default setting. So that's how we compare the setting files in the offline windows. To edit a setting file, we can right click the setting file and choose Edit Setting File Properties. So under this Edit Properties, we can change lots of properties of the setting files. For example, the firmware version. To change this firmware version is to make the setting files match to the relay you're using, so you can download the setting file into the relay. And another one is the serial number. So in case you have a serial number is locked into the relay, you want to change the serial number. Another is the order code, and by the order code we can use this option button to select each option. So the reason to do this editing is that you have a setting file you want to write into a different relay with a different order code. You can use this editing of the order code. So once you're done with all these options, just click OK, and this setting file is being updated into that a new setting file with the new properties like the firmware version, serial number, and order code. Sometimes we have too many setting files in the offline windows. We want to temporarily remove some from the windows. So to do that, we can click the setting files, right-click mouse, and choose Remove the file from the list. And then click Yes. So then this setting file is removed from the list. But the setting file is not removed from the local drive. So if you go to the check that directory of the setting file, feeder 102 is still there. It's not removed from the hard drive. It's just temporarily hidden under this offline windows. To bring this setting back, we can just right-click File and choose End Existing Setting File. Then we choose feeder 102. Then feeder 102 setting file is bring back to the offline windows. Once we made the changes on the offline Windows setting file, then we want to write the file back into the relay. There are two ways we can write the file into the relay. First is click the setting file, right-click mouse, and choose Write Setting Files to the device. Then highlight the device to write, click Send button. Just like most multi-link relay software. And another way we can do is just from the offline setting file, using the mouse to drag, highlight the file, and drag and drop into the device. So I'm drag, drop this to the online Windows feeder 101, and I got a message, are you sure want to save the setting files to the device? And click yes. Then we can see the progress bar is moving, and the setting file is being written to the relay. At the end, we'll see that the message setting file successfully written to the relay, and click OK. For this drag and drop method, be careful that you have to drag the whole setting file over the device. You cannot just dragging the like a partial settings, for example, the system or the protection only. That doesn't work with the 8 series relay. Sometimes we need to create a new setting files without having the protection relay device. So to do that, we can go to the offline Windows, click Files, then right-click mouse and choose and New Setting File. From here, we can give a file name. By default, it's called untitled.cid. We can give a name, for example, the generator 889 relay CID. Click Save. Then we can choose the type of the relay is generator. And for the different application, we can choose the different order code, etc. So for example, I want to have the advanced communication. I can choose 3A and ST multi-mode fiber cable with Wi-Fi connection, advanced cybersecurity, and then click OK. So now we got one 889.cid file is added in the offline Windows. To print a setting file, we can click the setting file, right-click mouse, choose Print Setting File, or we can preview the setting files, then print it. So click the preview the setting file. We can see we can choose the set points and the user-definable memory map, and we can choose only enabled features or all the features, and setting group 1 to 6. So click OK. Then we can starting the preview of the settings. So under the print preview, we can see that the setting files, you can click next page to see the different pages of the setting files. So all these setting files can be printed either directly through the printer, or we can just print this as a PDF. Just click printer button. You can choose your printer options, either the printer or the PDF. And that's how we print the setting file. As we mentioned in the 8SP-100 overview videos, there's the SR retrofit tools, and also we can convert the SR setting files into the 8 series setting file. So to convert the SR setting file, we need starting a new setting file, and then we can choose the initiate the setting files from the SR relays, and by clicking this setting file. So I got some setting files saved under my document, settings, SR. So I can choose this SR745 because by default I use the order code option 845. So then I can click OK to start conversion. If I want to convert my 750 file, I need to change my order code to be 850 first. Then I can select the setting file of the 750 extension. All the SR setting files must be within the version 5.0 or higher. If it's below version 5.0, you can do a file editing in the SR and the Vista software to upgrade into a version 5 or higher. So now I will give this file a name. Instead of using the default untitled, I will call this setting file SR750_850 and click Save and click OK button. I started the conversion of the setting file. So at the end of the conversion, we can see that a comparison table, the chart of the setting values and original setting name and original values. And we have different colors: green for successfully converted, orange for need verification, and red for the need verification. So that's all the settings being converted. Okay, so at the end, we got the one portion called set points not converted. So that's have only the folder name, but there's no setting. So that's all the set points not converted portion. So got quite of some settings not converted. Okay, so that's how we convert a SR setting file into the 8 series by using the SR750 as a demonstration. Within 8 series relay, we can simulate 3-phase fault without using 3-phase test set. So to set the test simulation, we can go to Set Points, Testing, and Simulation. For the simulation, we can simulate not only the analog CT-VT input, but also the LED contact input and outputs. For this demo, we're going to only demo how to inject simulated CT and VTs. So first setting is the simulating state. We can simulate pre-fault, fault, and post-fault. And usually we can use one pre-fault to test the metering. And the parameter is set under each setting screen pre-fault. We already entered the parameters, magnitude, phase angle for voltage and current. And be careful the phase angle, the negative values representing the lagging phase angle. So we also have the fault, and we can do this pre-fault to fault transfer by using this trigger. So we'll show this later, but for now we're going to do a quick pre-fault applied and to check the status of the front panel metering. So we can open the HMI display to see this parameter being applied to the front panel. So we're going to save this pre-fault state without triggering, and when we click Save, we'll see that the parameter is applied to the relay's front panel. So the next test we want to do is the pre-fault to fault trigger by using manually turn on, and this can also be done by using the contact inputs or the virtual inputs, remote inputs, or by any other flex operand. So for this demo, we're just using manually turn this on, and we're going to click Save. As soon as I click Save, this pre-fault stage will jump into the fault, which means 2 times CT. And also, when the relay operated, it will jump into the post-fault. So the post-fault parameter is 0 CT. And for the voltage, it depends on the CT position. Could be nominal voltage of the line, or could be the 0 voltage of the bus. So for this demo, I'm just using 0 current and voltage. So the element we're going to test is phase IOC element. This element is already enabled. The setting is 1.9 times CT, just because it's below the fault values, 2 times CT, and 3 seconds delay is used for this element, just for us can see that the the 3 seconds fault delay in the HMI display. So now if I click the save button, and we'll see that the jumping from the pre-fault 1 to 2 for the 3 seconds, then jump into the post-fault. And that's how we tested the Face IOC by using this simulation mode. And we can see that at the end, the fault current is cut off because we set them in the post-fault. This is similar like the 3-phase test set auto-off function. For some application, we want to keep this current applied without tripping the current. So there's 2 ways we can do. The first one is disable the triggering, set it off, and apply only the pre-fault. So when we apply only the pre-fault parameter will be applied. We can manually change the parameter. For example, the phase A current, we can set this to be 1. So then if we want to test this element, we can manually turn this to be 2 and click save. So 2 times CT is applied, but the relay will not jump into the post-fault even after 3 seconds. But for some application, we have lots of parameters. We want to dynamically change from pre-fault to fault. So we don't want to manually change. So there's another way we can do is to set the parameter of the post-fault same as the fault. So when the fault applied, the relay operated, it will jump from fault into the post-fault, but the parameters are the same, so we can still keep on applying these fault values to the relay and analyze the relay's behavior. So that's the introduction of how we use the test simulation to test the relay without using a 3-phase test set. In the metering of the CT bank, J1IA to IG measures the magnitude of the fundamental frequency, J1 RMS of IA to IG, including the harmonic components. Average current is the average current of the 3-phase currents. Underscore 1, 2, 0 represents the positive, negative, and zero sequence current. The calculation is introduced in the FMPR modules. Residual current, IN, is the vector sum of the 3-phase currents and is the actual earth fault current. The residual current is equal to 3 times the zero sequence current. The percent load to trip is the ratio between the highest 3-phase current and the lowest pickup settings among both phase IOC and phase TOC. If all elements are disabled, the values display as 0. VT metering depends on the VT connection. When VT is set to Y connection, metering will show phase to neutral values. When VT is set to delta connection, then only phase-to-phase values will be displayed. The symmetrical component calculation in delta is different with Y connection. Please refer to FMPR modules for the detailed information. The auxiliary VT bank has its own metering window. In the phasor display, 3-phase current and voltage can be set to different colors and different phasor sets to show the phase relationship. Frequency metering will show the frequency and the frequency rate of change for current, 3-phase VTs, and auxiliary VT. Frequency measurement is accomplished by the measurement of time between zero crossing of the composite signal of the 3-phase bus voltage, line voltage, or 3-phase currents. The main frequency tracking source uses three-phase bus voltage. The frequency tracking is switched automatically by algorithm to the alternative reference source, then three-phase current signal or line voltage if the frequency detected from the three-phase voltage input is declared invalid. If a stable frequency signal is not available from all sources, then the tracking frequency defaults to the nominal system frequency. Harmonic has a measurement of up to 25ths where all values are calculated every 3 cycles. Harmonic detection shows the harmonic of 2nd, 3rd, 4th, and 5th. The calculations are updated every protective pass. Power metering will show three-phase real, reactive, and apparent powers and power factor. There is a separate power factor metering value which is associated with power factor function under monitoring functions. If it is not enabled, then this power factor reading will be 0. Energy displays the positive and negative megawatt-hours and megawatt-hours, as well as energy measurement, reset date and time. The relay measures current demand on each phase, the reset date and time, maximum demand and date and time of each phase. Demand calculations are based on the measurement type selected under monitoring, functions, and demand. The relay also measures three-phase demand for real, reactive, and apparent power. Demand calculations are based on the measurement type selected under monitoring, function, and demand. Directional power metering is displayed when the directional element is enabled. The calculation is real power multiply cosine theta plus reactive power multiplying sine theta. Theta angle equals to RCA plus the calibration in the setting. When the element is disabled, the values displayed is 0. When arc flash is available in the order code, metering will show the arc flash high set current. RTD and maximum RTD temperature can be displayed in the Celsius or Fahrenheit degrees. The selection is made under Set Points, Device Installation, Temperature Display menu. Flex element operation signal values can be displayed if they're being set up in the Flex Logic Flex element. This will be covered in the training modules 8SP-106. Under the summary of status function, annunciator status is displayed for all 8 series relays. The annunciator needs to be programmed under the menu Set Points, Device, Front Panel, Annunciator. Breaker actual values will show the breaker status and trip close of the coil, as well as total arcing current. To get a reading, the breaker needs to be configured under System Setup, Breakers, and the breaker monitor under Monitoring. For the motor relay 869, if the switching device is set to contactor, then the breaker status becomes unavailable. Instead, contactor status will be shown. 9 switches status can be displayed when they are pre-programmed under System Setup Switches function. When the relay order code has an arc flash function, its light sensor and supervision over current and final arc flash output status are shown under arc flash. Contact input status shows each input status in the software. It won't show which digital I/O card the contact comes from, like F card, H card, etc. This information can be found from the relay front panel status contact inputs. There are 64 virtual input status that can be displayed under virtual input status. In order to use virtual inputs, they need to be enabled beforehand. This will be covered in the next modules 8SP-103. There are 96 virtual output status that can be displayed under Virtual Output Status menu. The virtual outputs are programmed using the Flex Logic Designer. This will be explained in detail in the modules 8SP-106. There are 256 flex state bits available from the flex state Modbus address 0531. The status values indicates the state of given flex state bit, which can be verified from the Modbus analyzer on the maintenance in the software. Communication status mostly talk about the IEC 61850 related parameters. We'll address this part in our 107 IEC 61850 module. Device status shows the device generic information like a self-test fault, maintenance required, in-service pickup and trip, etc. The active setting group number is also shown in the front panel. We will use this piece of information in the 8SP-105 control and monitoring module. Under the status menu, we can also see the relay information as we could see from the relay front panel. Plus, in the software, we can see also the environment information like temperature, humidity, and surge counts, etc. To check the events recorder, we can access this from the shortcut button from the toolbar, or we can go to the menu and click Records, click Events Records. Before that, make sure you select the correct device number. In this case, we're using USB. I'm going to click the shortcut button. And by the way, when you move the cursor, you can see that the description, this is for the event recorder. So once I click event recorder, I got to launch this event recorder. In this demo, I got Face ILC operated, so I can highlight the different events, the pickup level to the trip, and you can select different events. We have 3 events can be selected for different color. So this we can see this blue to the light green color. The time difference is like 3 seconds. That's the time delay set between the pickup and level. We can also see the magnitude for this event. This IA current is at 1000 amp, and also the CT frequency. Okay, so all these events are automatically recorded because in each element the events are enabled. So to check this status, we can go to see the protection. For example, this Face ILC. So the event is by default is enabled. If this is set to disabled, that events will not be recorded into the events recorder. And that applies to all the elements for the protections and contact inputs, outputs, etc. There are 3 ways to start the transient recorder. The first one is start from the transient recorder button on the toolbar. And the second is start from the menu, Records, Transient Records. And make sure that you select the correct device name before click the buttons or the menu. The third one is we can directly launch this from the events recorder. In the events recorder, we can see that the trigger of the transient recorder trigger button with a picture at the data columns. Then we can click this button to launch the transient recorder. So this is the Face ILC TOC operation, and we can right click mouse and drag to zoom in this portion. Under the preference, we can set the analog and the digital. We have multiple channels. We want to select or deselect some analog channels, so we can do this from this preference setting to select more phase or less phase, etc. So
that's the display part, and this is automatically set in the transient recorder setting. But let's just take a quick look, see what's the setting of the transient recorder, which is under devices, transient recorder. So by default, this transient recorder will trigger by any chip, but this can be set to any protection element chip. So we can set this to be specific to be face IOC or TOC or any other events. And also we get some other useful settings, is like the number of records, sample rate by default 32. So we will see that the difference between the sample rate of 32 and the sample rate of 8. If we want to record much longer events, we can reduce the sample rate just to see the longer events. And also we can reduce the record of the numbers. We get the less number, we can record much longer events. Trigger mode can be override or protected mode. So override, the new events cover the previous one. Protected, it just stop recording at a certain length. Trigger position, default to 20%, and we can also set this to be other position, for example 50%. So we can select the events to be recorded, digital, inputs, and also the analog. But here we're just using the default, but this can be customized to any other parameters. To use the data logger, we need first set up the data logger. So setup is under set points, data logger, and we can set function from disabled into continuous, and the trigger we can manually set this on, or this can be done by any other flex operand. And for this demo purpose, we're going to reduce the rate to be 1 second, and the source we're going to use the current J1, or this I can just manually type J1IA, and I just choose the mode to be sample, and there's totally 16 sources we can pre-program in the setup, and click save, enter the password. Okay, so now I'm going to use the current injection to inject the current, and also changing the magnitude up and down for a few seconds. Then we're going to launch the data logger to see the curve, the fluctuation of this current. And meanwhile, I can hear that my face IOC element is operating. Okay, so now I'm going to launch my records of the transient recorder, and there's no shortcut on the toolbar. We can only launch this from the menu, data logger. Okay, so now if I click read, so this is my records of the current. I just manually increased up and down, so we can see that's the time. By as we dragging this cursor, we can see that the magnitude is changing on the right side, and also we can see the time for that two different colors, green and the blue. That's how we set up the data logger and how we view the data logger data.
.850 quick setup includes in-service, nominal frequency, current and voltage sensing for the system. The protection elements includes phase, ground, and neutral IOC and TOC with simplified parameters. They are all on the same page, the The rest of the relays all have the separate pages for the system and protection. For 869 quick setup, its system includes device in service, nominal frequency, current sensing of phase and ground CT, motor nominal current FLA, etc., and switching device setting. Under the protection element, it has a typical motor protections, thermal model, short circuit, under current and under power, mechanical jam, and current unbalance. For 845 quick setup, its system setup includes device in service, nominal frequency, current sensing and voltage sensing. The transformer winding parameters include compensation method, capacity MVA of the transformer, nominal phase-to-phase voltage, connection, and grounding. Under the protection element, the main protection for the transformers are percent differential and transformer overload, plus other IOC and TOC elements. The protection summary will summarize all the protection, monitoring, and the control element. There's two ways we can starting this protection summary. From the online pane, we can just click the third button, the shortcut button, to start the online device protection summary, or we can start this from the offline windows, and we open the menus and click open the protection summary. So the name is called the protection summary, but actually it's a summary of protection, monitoring, and control. So we can see that on the top is the protection elements. Then we can going down to see the next is the monitoring elements, and the last is the control elements. So from this protection summary, we can quickly access to all the protection functions element in one screen. So for example, we can click the phase TOC function. So we'll start this TOC setting screen, and we can make some changes. For example, change this from disable to trip, and click save, then close it. So now under the protection summary, we can see this function turn into the green color. It's enabled and set to trip. And also we can see that what auxiliary relays are enabled. For example, in the phase IOC, auxiliary relay 3 and 4 are enabled. Under the top checkbox, we can check the other setting groups. So for example, we want to see the setting group 1, 2, 3, 4. We can just check these setting groups. We can see all these functions under each setting group. There's another radio button we can choose is all functions, or we show only the enabled. If we select only the enabled, so only enabled function will be displayed. So from this screen, we got only 4 elements: the phase IOC, TOC, and the load encroachment. Another radio button we can choose is select the type of the function. We can choose the trip, alarm, latched alarm, and config. So if I select only the trip, so only phase TOC and IOC1 will be displayed. If I set alarm, then only the phase IOC2 will be displayed. So that's the options under the summary, protection summary. We can use this summary to quickly access to the protection, monitoring, and control. We can check the maximum up to 6 setting groups settings of the protection. We can check the I/O card, and for this relay, because only the one output contact, so it's default to the F card and it's grayed out. And also we can check display all the functions or only the enabled functions, and the type of the function to be chip, alarm, latch, alarm, all the configurable. So that's what we can do from this protection summary screen. Firmware from the GE Restoration website. Second, we need to have the latest software. In this demonstration, I'm using the latest software version 2.2 to upgrade my relay firmware 2.0 into 2.2. The third one is the interface must be USB. If you're using other interface like Ethernet, you'll get a warning message. So now I plug into my USB cable to the relay. I'm going to use my quick connect into the relay. And under the maintenance, we got update firmware options. It pop up a message, will take up to 20 to 30 minutes. Click OK. Then we need login as administrator. Enter the password 0. Click send password to device. Now we're going to select the firmware. So now I have a version 2.2 saved on my desktop, J0J08CA220. The extension name is SFD. So I'm going to click open this file and click proceed. And it says the update will default the relays setting, so make sure you have already backed up your setting files before upgrade the firmware. So I click yes to proceed. And from the software side, we see that rebooting relay to upload mode, please wait. And also we can see that the relay front panel changed into the upload mode. So in the software, I got upload progress bar is moving. The boot firmware will be upgrade to the relay. This is the message box says. Okay, we got the message to power cycle the relay after boot to upload successfully. I'm going to turn off the relay and then click OK. So now in the relay's front panel, we can see that firmware write complete message. At the bottom, there's a progress bar is moving. Okay, I got another message. Boot 1 upload successfully. Power cycle the relay. I'm going to turn off them. Click OK. Now we have the main firmware uploading into the relay. You can see the percentage from both the software and the relay front panel. Now we got this message from the software. Firmware update successfully. Please wait for the relay to boot up, then cycle power again to complete the firmware update. So now this firmware update is complete. We just need to wait for the relay to reboot, and then we can start using this new firmware. The technical resources used for these modules are the manuals from all the 8 series relays, and particularly from the chapters of the software interface. Another resources we used is the USB troubleshooting guide, which is saved under the Vista software directory, which can be accessed from your local drive. That's all the technical resources we used for this 102 software interface module. Now, let's recap what we have learned in this module. First, we introduced 3 ways of connecting relay by using USB, which is the quickest way to connect to the relay. Another way is to use the Ethernet cable. This can be the Ethernet of fiber optic cable or RJ45 copper cable. This is the most practical way of application. And the third way is to use Wi-Fi connection, which needs some efforts to configure the router, but will be easier for the future connection, especially for the quick multiple relay access. In the setting file, we introduced how to read, write the setting files, also called download or upload setting files, and how we can copy, rename, compare, and edit the setting files. There are two ways of writing setting files: by right-click on the file and choose Write to Device, or use drag and drop, which must be applied to the whole setting file, not a portion of the setting file. When we remove a setting file from the list in the offline window, the file is not deleted from the computer, it's just temporarily hidden. SR setting files can be converted into corresponding 8-series setting file. At the end, there will be a conversion report to show which settings are converted or not. In the test simulation section, we introduced how to program 3 stages of pre-fault, fault, and post-fault, the tricks to do the metering test and the relay trip test. Test simulation is only in the online windows and cannot be saved into the setting file. In the actual value part, we introduced the metering readings, especially the calculation of the current and the directional power, then the status of various states, and lastly, the records of event records, transient records, and data logger. In the quick setup, we introduced 4 applications: the feeder, motor, transformer, and generator. Each quick setup parameters of the system and protection elements. In the protection summary, we showed how to access all the protection, control, and monitoring functions from one screen, how to display by enabled functions, 13 group number, and function types. In the upgrade firmware section, we demonstrated the whole process of upgrading one relay from firmware into 2.2, how to import SSD file, and then reboot the relay following the instructions in the software. In the resources, we introduced how to get the 8-series manual from GE website and the chapter we used for this module, software interface, and also the USB troubleshooting guide, which is saved under an Vista software directory. And that concludes this training module, 8SP-102 8-series software interface module.